Okay, let's review what you need to know for the Unit 2 exam on constant acceleration. The test will determine how well you understand and can do these things right here, these concepts. The first thing I really want to know is, do you know how to calculate the average velocity and instantaneous velocity of an object, and the average speed and instantaneous speed? Now, average velocity, what do you do for that? Well, we know that average velocity is delta x over delta t, right? So you need an x value, a final minus an initial, divided by some t final minus t initial. That is the operational definition for average velocity. Okay, now what is instantaneous velocity? It's how fast you're going and in what direction you're going, not over a span of time, a duration of, but right now, this instant. Well, how do you do that? Well, if you're looking at a position versus time graph, which I'm going to give you. Let's say you have something that looks like this, and you want to know, okay, what is the velocity at this time? How would I find the velocity at that time? Well, you take the slope of a tangent. You draw a tangent line, and you figure out what is the slope of that tangent line. So you take a delta x over delta t, but instead of the delta x over delta t being on the actual graph, it's on the of the motion of the object. It's the slope of the tangent line. And that'll be how fast you're going at that instant in time. Okay? Now I'm going to give you a position versus time graph like this, and I'm going to ask you, what is the instantaneous velocity at t equals, like, I don't know, 4 seconds or something like that. I don't know. But here's what I've done for you. I have drawn the tangent line for you on the test. And why? Because I don't want to grade 157 different answers, okay? But you're going to have to know that to figure out what the instantaneous velocity is, you need to take the slope of a tangent line. Now, average speed, what is the operational definition for average speed? Well, it's the total distance traveled over the total time. Now, what if I give you a graph where, this is position as a function of time? What if the object goes up, goes over, and comes back down? Well, what's the total distance traveled? Well, here they went up, and then they went all the way back, and you have to add this distance plus this distance regardless of direction. It's the length of the path that they traveled. That's what total distance means. And then you just divide that by the time. That'll be your average speed. So it's a different operational definition. I think we covered that in Unit 1, actually, as well. But I'm reinforcing it here. Instantaneous speed. What do we mean by instantaneous speed? I mean, the slope. The instantaneous speed is the magnitude of the instantaneous velocity. So if you, like in this example that I did here, maybe this has a slope of negative 1.5 meters per second, but the average, the instantaneous speed is just 1.5 meters per second. Not negative 1.5, because it doesn't, with average, with instantaneous velocity, what does the sign mean? What does the plus or minus? It means, is it going to the right or the left, or is it going down or up? Well, with speed, you don't care about the down or up. So it's just kind of the absolute value of the instantaneous velocity. Okay. Actually, these two I'm going to kind of test together. I'm going to give you a position versus time graph, and I'm going to expect you to find the average velocity for a certain time interval and I want you to find the instantaneous velocity for a given time, so slope of a tangent line. So this is more definition kind of stuff, and this here is using that definition to solve problems. Okay. Then I'm gonna what if you're given a velocity versus time graph, and looking at it now, I'm probably not going to give you a velocity versus time graph. I'm probably going to give you velocity versus time data, and you're going to plot that data to get a velocity versus time graph. And from that, I want you to get a kinematic stack. I want you to determine displacements and accelerations for given time intervals. And I forgot. I want you to develop a math model, right, for velocity as a function of time. The equation, right? V equals AT plus V naught. What is the acceleration? What is the initial velocity? And well, the displacements and accelerations for given time intervals, you're going to have to look at the graph. Basically, there we're dealing with slopes, right? If you have a velocity versus time graph, the slope of that is your acceleration. The area underneath the graph is your displacement. So make sure you can go back and forth. I mean, if you can draw the kinematic stack, you can figure out the other stuff. Then I'm going to give you problems, and I want you to solve these problems, and I want you to draw the kinematic stack for these problems that involve constant acceleration. And so make sure that you have an equation list that include the kinematic equations, because you will have to use them. On these problems, I'm going to want you to use the given, find, solve format. And I'm going to want you to use the kinematic equation. So write down the kinematic equation you're going to use before you start substituting in values. Okay, because I want to know what you're doing. And then, that way, hey, if you show the kinematic equations you're trying to use, and then you make a mistake, you're going to get lots of partial credit. But if you don't show which equation you're going to use, and then you make a mistake, and you lose a lot of credit. So I want to see that you can do that. Also, with this, there could be problems where there are two different accelerations in the problem. Like a car is speeding up, right? A car is speeding up and then reaches its maximum speed and then it slows down. So you'll have a positive acceleration, speeding it up, and then you'll have a negative acceleration, slowing it down. And so you break the problem up into two pieces so you can figure it out. And obviously, if you can draw the kinematic stack for that situation, you can pretty much solve any of the problems that it's asking for. Then I'm going to give you one or two free fall problems. Again, a free fall, we're going to use the accepted value for gravity. The acceleration of gravity is being down 9.8 meters per second every second. And I could give you a problem where, like we did outside where we threw the ball straight up, and you go up and down and you record the time, and from that you can calculate what the velocity of the ball is at the bottom of the flight, what the maximum height is, that sort of thing. Or we might, I might give you a problem where we just drop a ball from a tall building, and how much time does it take to hit? What's the final velocity of the ball just before it hits? What's the height of the building? That sort of thing. These problems are very similar to these, except the acceleration is negative 9.8. So there'll probably be some questions here, and maybe 4 or 5 problems. And, so the test will probably be worth about 50 points. Very similar to the last one. Okay. So Here's how I want you to study for this. First of all, hopefully you've already made one, but you should at this point be making an equation list. And you should be using that equation list to do your homework. And add to it as you do the homework, as we move on to new things. So this equation list you're going to make for the exam, I want you to keep it and use it for the rest of the year. Only equations on your equation list. Once you've done that, try to put yourself into my mind and say, I'm going to write a test. I used to do this when I was a student at Cal Poly. And I would say, okay, what kinds of questions will this teacher ask? And then I try to write my own versions of them and see if I can solve them and answer them. That's an excellent way to study, especially if you have a study partner. You write a problem that you think I'm going to come up with, and you have a study partner try to solve it. Okay, you can do it online or however you want to do it. Also, you can pick 4 or 5 problems from the homework that we've done. 7 assignments, and or a couple starters, and turn it into a test, and see if you can do those problems in a short period of time without looking at the answers that are in your notebooks. A simulated test. If all you do is look through your notebook and go, oh yeah, I understand that problem, oh yeah, I understand that problem, oh yeah, I understand that problem. Can you do that problem independently if you don't see the answer? There's a big difference between understanding the solution and being able to produce the solution. So the problems you're going to get on the test, look, I've looked at the assignments I've given you. I'm basing the test problems on the assignments I've given you. They're not going to be identical, but they're going to be the same kind of problem. So if you can do those independently, then you're ready for the test. Okay? So with a good equation list, practice that. Make sure you understand those operational definitions, and you should be fine. Okay? Any questions? Okay. That is all.